Okay, so from here on out, we are going to assume that all the op amps are ideal. And so what that means is if they're ideal, we know that Vp equals Vn, or another way to write it is V plus equals V minus. I think I heard you say that. And that Ip equals In, that equals 0. So, you know those things. I said one reason for giving you those pages at the beginning was in case you recognize something. And if we look at this one right here, okay, so if we look at this op amp that we have here, and we compare it to this non-inverting amp that I have here, it's the same thing. The only thing that's different is it has this load resistor coming out of VO, but that's just, I mean, that's not changing any of the what's going on with the op amp. So in this instance, which is usually a rare one, we recognize it and we say, oh, okay, well, that's what this one is. And so we know that V out is going to equal R1 plus R2 over R2 times V source. Now let's label what those things are in our problem. This is V source. This is our R1, which currently is unknown. This is R2, right there. And we are supposed to assign a resistance value to RF so that the circuit would deliver 75 milliwatts of power to RL. Okay, so when we're looking at RL, let's see, do we know what, we know what an RL is. RL is 3 kiloohms. And so we want to think about one of our power relationships that has voltage in it, because we're going to get voltage and resistance. And I can never remember the different power formulas. I just always derive them. So I know P equals IV. I've got that one. And I know Ohm's law, that V equals IR, which means that I equals V over R, which means that P equals V squared over R. And it's sad that at this stage I have to derive that every time, but I do. Okay, so I am going to scroll up, so hopefully you have the information that you need, or I'll rewrite it. R1 was RF, R2 was 4 kiloohms, Vs was 3 volts. We have that power equals V squared over R, and we are trying to get to a power of 75 milliwatts. So we want 75 times 10 to the negative 3 to equal V squared. Well, we had that V equaled R1 plus R2 over R2 times Vs. So that's RF plus, and what was R2? R2 was, oh, I wrote that, 4 kiloohms, plus 4 kiloohms over 4 kiloohms times 3, and all that squared over the resistor that we're going through, which they told us was 3K. So let's see, multiply, so 75 milli times 3K, a milli and a K cancel each other out. And then I have RF plus 4K over 4K squared. So 75 times 3 is 225 equals RF plus 4K over 4K squared. And we take the square root of both sides, and the square root of 225 is 15 equals RF plus 4K over 4K. And then 15 times 4K is, wait, did something wrong.
Isn't it 3 was supposed to be squared?
The 3 was supposed to be squared. So there should be another 3 over here. Oh no, the 3 was not supposed to be squared. Well, yeah, this 3 was supposed to be squared. Yeah, oh, I lost a 3. That's what I did. I lost a 3 inside here. Let me go back. Okay, so there's the 3 there inside, and that's, I lost that. So times 3 squared, and then I still have a times 3 there. Yeah. So that's where my mistake was. Now divide by 3, RF plus 4K over 4K, or 20K equals RF plus 4K, or 16K equals RF, or RF equals 16 kiloohms. Okay, so for this one, we are supposed to obtain an expression for the voltage gain, which is, and this is how the voltage gain is defined, as the output voltage over the source voltage for this particular circuit. And nothing, no numbers given here. We're just supposed to analyze this circuit the way the other circuits were analyzed in your book or in class, to show what they did. So we can start by saying that we know that IN equals IP equals 0, and Vn equals Vp. So we know that. And if we look here, right here, since VO prime, so I have VO prime identified there. If they weren't identified there, then you probably should, because that's probably going to be something to help you with your problem. Then since IN is 0, then we can do voltage division here, because our total change in voltage from ground to here is V0 prime. So by voltage division, Vn equals our total change in voltage, which is VO prime, times R1 over R1 plus R2. Now, looking at this part of the circuit right here, looking at that part of the circuit, and knowing that IP is 0, so we know IP is 0. What does VP have to be? I can't hear you. It has to be VS, because there's no current running through there, and so it has to have the same voltage. There's no current running through that resistor at all. So VP has to equal VS, and then it does also have to equal VN. So it always has to equal Vn. But now we know that Vn also equals Vs. So that means that we can say that Vs, do I want to say that? Yes. So Vp equals Vn, and Vp equaled Vs, and so I can say that Vs equals VO prime R1 over R1 plus R2. Or VO prime equals, multiply both sides by the reciprocal of this, Vs times R1 plus R2 over R1. Okay, so, but we're supposed to be trying to find V out. So now I'm going to do voltage division again. So I now have an expression for VO prime, that's right here. So by voltage division, this is VO right here. VO is going to equal my total change in voltage, which is this expression right here, Vs times R1 plus R2 over R1, times, and then voltage division tells me it's going to be times this resistor RL over the sum of the two resistors RL plus R3. Or, actually I was supposed to be finding an expression for VO over Vs. So divide both sides by VS. So VO over VS, and this was R1 right there, equals, and then just rearranging things a little bit to make it look prettier, RL over R1 times R1 plus R2 over RL plus R3. Questions on that?